everyone, welcome to Lectures by Aparna. In this video, we will discuss a question from the topic Sequential Circuits. I will read the question. A ripple counter using negative edge triggered D flip-flops is shown in figure below. The flip-flops are cleared to 0 at the R input. The feedback logic is to be designed to obtain the counting sequence for the circuit which is shown below. What is the correct feedback logic? So we can see that this circuit is an asynchronous counter. Another name for ripple counter is asynchronous counter. So clock signal is given only at the first flip-flop. The output of the first flip-flop will act as clock signal for the next flip-flop, and the output from the second flip-flop will act as the clock signal for the third flip-flop. So here we have to find the logic circuit that gives clear signal to all the three flip-flops and reset them. So they will execute a counting sequence, then they will come back to initial state 0 and then again continue the counting. So we have to find the condition when they are reset to 0. It is said that the flip-flops are cleared to 0 at the R input. So initial value in all the flip-flops are 0, which means Q0 equal to 0, Q1 equal to 0 and Q2 equal to 0. Here D flip-flops are used. So it is said in the question that these flip-flops are negative edge triggered. It is said here. So let us draw the clock signal first. These are the negative edges of the clock signal. Now for Q0, when the negative edge of the clock pulse come, whatever input is present at D0 will appear at Q0. D0 is connected to Q0 bar. So initially it is said that all flip-flops are reset to 0. So Q0 is initially 0, which means Q0 bar is equal to 1. So this 1 will be present at D0. So this 1 will be present at D0. When the negative edge of the clock pulse come, this one will appear at Q0. So Q0 changes its output from 0 to 1. So initially Q0 is 0. When the first clock negative edge of the clock pulse come, it changes its state from 0 to 1. Again Q0 is now 1. So Q0 bar is 0. So this 0 will be present here. When the next negative edge come, it will change its state from 1 to 0 because the input present here is 0 from Q0 bar. Now during the next negative edge, the output present is Q0. So Q0 bar is 0. This 0 will be already present at D0. So when the next negative edge come, this D0, that is 0, will come to output Q0. So from 1 it will go to 0. Again it toggles at the next negative edge and changes its state to 1, and this process continues. So we get like this. Now let us see Q1. These are the negative edges of Q0 which is acting as the clock pulse for next flip-flop. So at these negative edges, let's see what happens. Initially the value of Q1 is 0. Now when the first negative edge comes here, what happens? This flip-flop will toggle because Q1 bar is connected to D1. So when Q1 is initially 0, when Q1 is equal to 0, Q1 bar is equal to 1. So that 1 will be present here. So when the first negative edge come, this 1 will appear at Q1. So this output will become 1. Which means the output has changed from 0 to 1. Again at the next negative edge, this changes to 0 and this process will continue. So you get like this. Now let us see Q2. These are the negative edges of the output Q1. This Q1 is acting as a clock signal for the third flip-flop. So we have to find Q2. At these negative edges, this Q2 will change its state. Initially the value of Q2 is 0. Now when the negative edge come, it will go to 1 until the next negative edge come. And then it will change its state only at the next negative edge. So this will be Q2. So looking here, we can see that the counting sequence is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. Here it is said that the counting sequence is from 0, 0, 0 to 1, 0, 1. So only up to this the counting happens, and after this it will go back to 0, 0, 0. So the condition where the flip-flops have to be reset is this 1, 1, 0. That is when Q2, Q1 and Q0 bar comes at the input of some logic circuit. The output of that circuit must give 0 to clear all the flip-flops. This can be obtained if you connect Q2, Q1 and Q0 bar to a NAND gate. Let this be output F and let this be Q2, Q1 and Q0 bar. This is the truth table of 3 input NAND gate. You can see that only in one condition it gives 0. That is when A is equal to 1, B is equal to 1 and C is equal to 1. So here if A is equal to Q2, B equal to Q1 and C equal to Q0 bar, it means that when A is equal to 1, Q2 will be equal to 1. And when B is equal to 1, it means Q1 is equal to 1. And when C is equal to 1, it means Q0 bar is equal to 1 or Q0 is equal to 0. So this will satisfy the condition. Q2 equal to 1, Q1 equal to 1 and Q0 equal to 0. Because when this condition happens, the output from here will become 0 from the truth table of the NAND gate. So you can see that the output logic for the NAND gate F is equal to Q2 into Q1 into Q0 bar, the whole bar. So that will be the output logic F, and so answer is option A. This is how you do this question. If this video has helped you, please do subscribe to my channel. Also don't forget to like and share this video. Thank you.